Welcome back, Algebra 1. Welcome to the last day of class. Well, the last day of lessons. You still have a quiz that's due on Thursday night, but this is the last lesson we're going to be learning this year. And I hope that everybody had a good year, even though the last couple months we were all stuck at home. I hope in the fall everything's nice and we can go back to school, or at least we have a nice setup for online if we need it then. Anyway, let's get started for today with our last discussion of data. So let's talk about the last topic for the year and the last topic about data for this year. So we're going to talk about measures of spread today. We talked about measures of center. That's when you want to find the average or the mean, maybe median, mode, things like that. Those are measures of center, right? Where is most of the data sticking together? Did most people get an A+ on the test, or did most people get a C? There's a reason C is usually the average. Then we talked about how to represent data, right? We can draw a dot plot. We can draw a bar graph. We can draw a histogram. Those are ways to look at the data and see where are the different clumps and gaps. What does our information look like? How many students are getting A+, things like that. Today we're going to talk about measures of spread. Measures of spread will tell us, are there some parts of our data that are way too far away? Or how far does our data go, right? If you look at a test score for a class and most people get a B, a few people get a C, one person gets an A, and then one person gets an 0%? What happened there? Is that real? Like, how do we know if that's an important part of the data or if it's an outlier? And we'll talk about that today. So I'm turned around. There we go. The first thing that we're going to talk about, all of this today is talking about variation, right? How far does the data spread from itself? Is all the data very close together, or is it farther apart, and we have to think about why is it farther apart? Okay, so the first thing that we want to talk about with variation is the minimum. This is simple, right? We probably know what minimum means already. Find my red marker. So the minimum number, well, before we even start with that. Okay, so the first thing we wanted to do almost every time that we have some data, here's my data for today. This is what we're going to be using in the class. Not on your assignment. Your assignment's going to be different. But in the lesson today, we're going to talk about attendance at a fundraiser. So these are the attendance numbers. How many people go to this fundraiser each year? So one year it was 42, then 38, blah, blah, blah. So we want to look at these numbers for 9 years of a fundraiser. How many people went to the fundraiser? The first thing we want to do, almost all the time when we have data, is put it in order. So we start with 38. And I'll skip ahead to when I have it all in order. Okay, there we go. So I put all of my data in order. All the values are in order from smallest to largest. Then I need to start with my measures of spread. Some important things to start with are the minimum. So what is my minimum? That is the smallest number. So the smallest number is 38. Nice. Then we want to find our median. What is the middle number? Well, our middle number, I'm going to count into the middle. 1, 1, 2, 2, 3, 3, 4, 4. So the middle number here is 48. Okay. We remember median from 2 lessons ago. It is the middle number. If you have 2 middle numbers, you have to take the average of them. We'll see that in a second. Okay, something else that we want is the maximum. This one's easy too. Since we put them in order, we want the largest number. That's our maximum. Okay. The maximum is 96. I don't like that 9. 96. A little bit better. Okay. These are the easy ones, the easy measures of spread, right? How far does it go? It goes from minimum all the way through median, all the way up to maximum. Real quick, what could we say is the range of this? What is the range of our data? Oh, I'm getting off the grid. Here we go. What is the range of the data? Range is maximum minus minimum. So it's 96 minus 38, which is 58. Okay, we don't need that right now, but it's good to know. Okay, once we have these three, the minimum, the median, and the maximum, there's two new things we want to find out. One of them is called the lower quartile. This is the number that tells us the bottom quarter of all the numbers. Okay? So this is, how do we find this? What we need to do is the median of the bottom half. Median of lower half. So here's the median. That's the middle. So we cut it in half. Now my lower half is these four numbers. So what's in the middle of those? Take one off, take one off. There's two numbers in the middle. So we need to do our mean of them again. So when we have two numbers left when we're doing the median, we need to add them up and divide by 2. Okay, so 42 plus 45 divided by 2 is 43.5. That's our lower quartile number. 25%, 1/4 of all the numbers are lower than that. Okay? Then, if lower quartile is the median of the lower half, upper quartile is going to be the median of the upper half. Exactly. So we do the same thing for these four numbers, the four top half numbers, right? We cut it in half. We cut our numbers in half by finding the median. Now we're going to find what the top half's median is and call that the upper quartile. So take one off, take one off. We have 2 left, so we got to do the same thing here, where we say 55 plus 62 divided by 2. 55 plus 62 divided by 2 equals, and this one's going to be 58.5. So that's our upper quartile. So what the quartiles mean is that half of the data, half of our numbers, is between these two numbers. So 43.5 to 58.5, half of our numbers are in that range between them. And that means that half of our numbers are outside that, 1/4 on the bottom and 1/4 on the top. So these are good to get ourselves an idea. Now we're going to use these to find out if we have any outliers. So let's look at outliers. Okay. Outliers mean numbers that are so different, numbers that are very different from the rest, right? If I have test scores and everybody in the class, we have 30 people in our class, 29 people get an 80% or 85%. They get a B. 29 people get a B. And one person gets an A+. That A+ is the outlier, right? Everybody else was in the B's, and the A plus is way outside of that, very far away. So how do we know? But if that one's very obvious, right? That answer is very far away. But what if our numbers are spread around more and we can't tell, is this an outlier or is this normal? This is how we find out if it's an outlier. And when we find an outlier, that's something interesting about our data that might tell us some new answers. In real life, right? This type of data is used in real life jobs all the time, right? Say you work at the city and they get complaints about, oh, there's a pothole on my street. Oh, there's a pothole on this street. If you suddenly get 1,000 complaints from one area, that's an outlier. That's extra interesting, and we might want to investigate. Okay. So now we're going to talk about outliers, and to find outliers, we use interquartile range. Interquartile range, we're also going to call that IQR. So I don't have to write it every time. IQR. This is the upper quartile. So IQR is the upper quartile, upper Q minus lower Q. Upper quartile minus lower quartile. Okay? So we're using the same numbers, right? I have them in order here from the last board. So let's go remind ourselves, what was our upper quartile and lower quartile? So our upper quartile is 58.5. Okay, let's put that over here in purple. 58.5. And we're going to subtract the lower quartile. So minus, and what was the lower quartile? 43.5. Okay. Let me get the camera back. All right, that's good enough. Come here, marker. No. Clipboard? No. There we go. 43.5. Okay. Which equals, so our interquartile range is going to be 15, right? Yeah, it's 15. Then we need to, that's step one. Interquartile range is step one. Then step two is, so I, Q, R times 1.5. So that is 15 times 1.5, which equals 22.5. Okay, this number, let me put the point in there, make sure it's there. 22.5. That number tells us where our outliers are. So we're going to look to see if we have any upper outliers. So what we do here is we do, what color is that? Pink. Upper quartile So the upper quartile plus this number, the IQR times 1.5, so 22.5. And we're going to find out our upper quartile was 58.5 plus 22.5, And it turns out we get 81. Okay. Now we want to look, do we have any outliers that are numbers bigger than this in our data? So this is our check number. We take this number now that we've found it out, right? Upper quartile plus the answer to this part, IQR times 1.5. If you add those two together, this is your checking number. We go back to our data and we say, is there any number here that is bigger than 81? Yes. So 96 is an outlier. If there's a number bigger than it, bigger than the upper outlier number, we get 96 equals outlier. Okay, so numbers that are bigger than that one are outliers. Then we do a very similar thing, a lower outlier. We take lower quartile number minus that same number. Minus 22.5. Okay, so the lower quartile number was 43.5 minus 22.5 equals 21. So now we go check. Are there any numbers smaller than 21? So for the lower outlier, we want to look smaller. For the upper outlier, we want to look bigger. So are there lower numbers than 21? Check our data. No, 38 is our smallest number, and that's bigger than 21. So there is no lower outlier. So this data only has one outlier, 96, and it's an upper outlier. Okay? So that 96, so remember this data was attendance at a fundraiser. So how many people go to this fundraiser each year? So most years, 38, 40, 50, that's pretty normal. Then one year, whoa, 96 people showed up? That's an outlier, right? What happened that year? Why did so many people go that year? I don't know. Did we advertise it better? Were there cookies there and everybody wanted cookies? I don't know. Was it a random happening? But that's what the data tells us, is that year we had so many extra people. We want to figure out how we can do that again. And that's how the data and outliers can help you in all of life, right? These get used all the time in jobs. If you go in advertising, engineering, news writing, everything where you need to figure out why data happened, which is most jobs. Teaching, everything. All right, that is it for today. And that means that we are all done for the year. You have a quiz that is due on Thursday. You also have Alex that is due on Thursday. So if Alex and a quiz are due on Thursday, along with this lesson, so you have all week to finish your last work. I need it by Thursday night because I have to put grades in on Friday. So after Friday, boom, it's done. Okay. So we're all set here. I'm going to go log in and get ready for the lesson if anybody wants to ask any questions. All right. See you later.